Hi guys, I realize I talk a lot about statistical significance, and not everyone knows what I mean when I say this. And even if you do know statistical significance, or you've calculated it maybe in the past, or you studied it in school, a lot of people don't have an intuitive understanding of significance and why it's important. So I thought I would do kind of a crash course in this, hacker's way of proving this is important. I'm using some scripts in Jupyter notebooks, some Python scripts. You don't need to worry about the code. Just ignore that. I'm really just going to use this as a way to simulate, lots and lots of rolls of the dice, basically, to show you, what's likely or unlikely when it comes to seeing, new variables pop up. Right. So don't worry about the code. Don't worry about the statistics. I'm not going to make you do any math, really. I'm just going to walk you through so you get an intuitive understanding with a real marketing example. Cool. So first, we want to look at the mean, the average, because it's very important to calculating statistical significance. So if you have a campaign, say campaign A, and these are the cost per acquisitions that you've seen every day for the past 7 days. On the first day it was $20.50, then it was 21.1, and so on and so forth. You're seeing that it's fluctuating each day as normal. That's pretty typical. But you want to kind of get an average. You want to see, how what is the average CPA for the past 7 days. So this would be calculated in Facebook ads or Google ads or in your reports typically. But to find the average, you just need to sum up all these values and then divide by the length. So how many values are there? So you'd sum up these numbers and then divide by 7. So the average is $21. Cool. So hopefully you're with me there. Campaign B, we're going to do the same thing. We're going to calculate the average, and you can see it's pretty much the same. $22, $21, not that much difference. But if you look, we have something concerning in this campaign. We have a value of $30. It's never been as high as $30. Sometimes it's as low as $11. So the client's worried. They're like, "Can you please pull back spend?" Or maybe you're seeing this before the client. You're wondering how you're going to explain that the CPA has shot up so much. It's gone up by say $4 since yesterday, and quite a lot since 2 days ago. It's basically tripled. So is this something to worry about? And the mean doesn't really tell you anything there, right? $22 is pretty much the same as this, and but this is a much more stable set of numbers. So how do we measure this variance, these differences? And that's where we come to standard deviation. So maybe you've heard of standard deviation. Again, here's the definition, but it's basically a measure of how spread out the numbers are, right? So how much jumping around there is between the numbers. I won't go into how to calculate it. You can look that up. You never really need to calculate it because there's always a formula to do it for you. So in Python, I can do this, stdev, and then it works out the standard deviation. So it's a 1.52 standard deviation. It goes up or down by 1.52 typically for campaign A. Whereas campaign B, it's going up and down by $8. So that's a bigger deviation, probably thanks to $30 at the end there, right? So much more deviation in campaign B. You might want to calculate actually your standard deviations for campaigns, just because it'll give you an extra bit of information. So you don't necessarily have to look at daily in order to see these strange anomalies. Cool. So now, what is the standard deviation if we just looked at the normal days, right? So if we got rid of this outlier, we just looked at everything up to the last digit, right? So that's going to grab the last up to the last digit, and the standard deviation is still pretty high, but it is skewing the result upwards here. Okay, so anyways, statistical significance. Now, standard deviation is fine, but it still doesn't really tell us, whether this is a normal result or not, right? It doesn't give us an intuitive understanding, and we'll probably would have taken action by now. So we maybe would have made a change we didn't necessarily need to make. We don't know if this $30 is normal to see, or if it's it's high enough, like it's a significant value that we need to take action. And that's what statistical significance is trying to measure. It's basically saying, how unusual is this value? What are the chances of it randomly occurring? And that's important to know so we don't overreact. There's a phrase I like to say, it's like chasing ghosts. I see this a lot from newbies, or people who don't have that much experience in Facebook ads, Google ads. They're like constantly changing bids and budgets, but then they change it up, and then performance drops, and then they change it down, and then performance goes up. And they're constantly chasing ghosts. They're making a lot of changes, making a lot of noise in the data, without any kind of significance in what they're doing. Especially bad for B2B, when you can only really have like one conversion for a keyword per month, in some cases, right? So it's really, really important to understand statistical significance. So if you don't have it, you can make choices around cascading significance, which I cover in this blog post. I recommend here, like if you can't get statistical significance based on your conversion event, then basically try and choose a conversion rate higher up the funnel. So if you can't get significance based on qualified leads, maybe optimize towards leads, or even to people who spend more than 3 seconds on the website. Anyway, I'm not going to get into that too much, but in order to understand why this is important and to make these difficult trade-offs, you need to understand significance in the first place. So let's take a look at campaign B. Same figures here. What we're going to do is run a simulation, and this is what coding with Python is really good for. Is you can actually run thousands of simulations if you want to, and see what would happen, right? So this is a relatively simple one. We've got our normal days, which is everything up to the last one. Then we've got just the last one here. Then we're working out the mean for the normal days and the standard deviation for the normal days. And then a test, this is a function here that's running a test for us. What we're doing is we're taking part of the normal distribution. That's basically where the values look like this, like a bell curve. You'll see this if you measure people's heights. Lots of people measured around the average height, and then there's some extreme outliers on either side. And lots and lots of statistical phenomenon. You can see this type of shape. So what this is doing is taking a normal kind of bell curve between 0 and 1, and then shifting it up to where the standard deviation and the mean is for our data set, right? Cool. So then what we're doing is taking this test and we're running it 10,000 times, right? And we'll see, it's essentially like rolling the dice 10,000 times, right? We're going to see how many times each option comes up. And that's what it's plotting here. So it's basically saying, the blue blocks here, it's a histogram. It's basically saying, like, when you run, if we ran this campaign for 10,000 more days, and the behavior stayed consistent to this, to these normal days, what would this look like? How many times would we see the value 30? And the black line here is 30. That's the value that we saw. So we can see that it's actually not that far close to the end. There's still quite close to the middle in terms of the samples, and we can actually calculate this. So we can say, how many times did we get a number that was more than the anomaly, anomaly day, in the tests, and then divide that by how many tests there were. And we can see that 12% of the time, this 30 shows up, right? So this is not statistically significant. For it to be statistically significant, it has to be 5% of the time, typically, right? That's the measure that most people use. Or if they're generous or being less scientific, more aggressive, you could say 10%. But even under that, it's not statistically significant. If you make this change and you kind of bring the budget down, there's actually a pretty high chance that what you're making a change on is not real data. It's just noise, right? It's just randomly being at 30. Sometimes it's going to randomly be at 10, and therefore you shouldn't bid up the budget when it's randomly at 10 either, right? So that's really, really important to understand, that, even though 30 might seem like a big amount, it could still be, just random noise, and it's very, very likely, actually 12% likely. Now, what happens if we, ran the campaign for another day and then we saw, another high value here? So we see this value of $42. Like, now, what's the chances of 42? Surely this is statistically significant, like a big enough difference, right? So run the same thing again, 10,000 times. And here we go. So actually, yes, this is statistically significant. This is a big difference, right? This is not likely to be random noise. This is, it looks like a real change in the account performance. So, the funny thing is actually that, we still see it 75 times out of 10,000. That's, low enough that we can ignore, because only 0.5% of the time will we be wrong. But that should really blow your mind. When something is statistically significant, it means that it's still 5% likely to happen, right? You're still going to be wrong, some of the times, right? You're still going to be wrong 1 in 20 times if something's statistically significant. So not even calculating the statistical significance and just making changes without this, you're kind of really messing up, right? Now, when you first learn this, when I first learned this, I was like, wow, why don't we go for 1% significance, right? Why don't we be really, really sure about making changes? But the downside is that, we're not in a lab, we're not scientists. Like, we like to be scientific with our marketing, but we don't have the kind of funding or time to wait a long time for changes, nor are the changes that we're making irreversible. Typically, if you bid up, you can bid down. It's not a big deal most of the time. We want to be mindful of significance because it helps us make better strategic decisions, but we don't want to be chained by it. We don't have to have reproducible results in a lab typically. We just have to be confident that we're making a decision. And if 5% significance makes you confident, like it does for scientists, that's great. You're still going to be wrong 1 in 20 times. But if you need to be more aggressive and you're more worried about budget, it's more of a conservative client, or you're just making smaller changes but that are more reversible, then you can, it's fine for you to go to 90% significance or 80% significance, or even just eyeball it, and maybe just plot like, how big is this value? How different is it from the rest of the numbers? So that's hopefully giving you a better understanding of statistical significance. Also, hopefully, kind of is explained to you what we're trying to do here when we look at the test duration calculator. So what this is kind of doing the significance, before the fact. So it's saying, given, there's X% conversion rate, and we want to grow by this much, and we have this many tests to run, this many visitors, how long should we have to run the test for to be statistically significant, right? So it's a little bit of a different calculation, but it's essentially trying to get you in a situation that you don't, conclude a test too early when, the figure is down here, right? And there's a lot of fluctuations as you run the test, as you guys have probably seen. What you don't want to do is not give yourself enough budget to run the test and be really sure about it, because the downside of not understanding significance or not kind of doing test duration calculator is that you might run too many tests for your budget, or too many tests for how many visitors you have in your website or in your email list, and that will mean that your test won't be conclusive, and that's really, really hard to explain to the client, right? When you're saying, I've run a lot of these tests, but they all basically perform the same, or like some were up, some were down, but then when we rolled it out, it reverted back to what it was before in terms of performance. It's very, very easy with this stuff to make a lot of changes and see no actual aggregate uplift over 6 months. So really, really important that you at least kind of understand these concepts enough to talk about them with the clients, kind of explain to them why we do this. I think it's really, really important, in particular for the strategists, to be able to kind of understand this at least. I know we were getting questions about this from some clients, especially the bigger ones. So it's good for us to have an answer, or even if we don't know this much about it, at least we kind of understand why it's important and we can ask the right people. So hopefully that's really helpful. I'm trying to teach it in a way that's a little bit more intuitive. So hopefully that was useful. The way you normally learn this is by reading math books, and nobody likes math books, apart from mathematicians. So we need to find kind of easier ways, more intuitive ways to understand this. If you guys have any resources that you found helpful, feel free to share them with the team as well. Okay, thanks.